Okay, so for the warm-up, hopefully you did this on your own. If not, turn off my recording and try it on your own. So there are 10 runners, and how many ways can the runners finish the competition? So it'd be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or we could think of that as 10 factorial. And how many ways can 3 of the runners finish first, second, and third? So now we only have 3 blanks. So there are 10 for the first spot, 9 for the second, 8 for the third. And then finally, how could we rewrite the answers to the above questions using factorial? So this, I think, is going to be a little more challenging. A, as I already said, could be 10 factorial. And for the second part, this one I think is harder to see, but essentially what this is, so this goes here, and then what we could do is we could think of this one as 10 factorial divided by 7 factorial, which is this one. And let me show you, that'd be because you have what I have up in part A. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But then you're dividing by 7 factorial. So all you'd be left with is your 10 times 9 times 8. And just to show you, this could also be 10 factorial divided by 10 minus 3 factorial. Okay? What I just did is what is called a permutation. So a permutation, I didn't make this blank big enough. A permutation is an arrangement of objects where order matters. So what I mean by that is, if, excuse me, if Ben, Chip, and Yoon are in a race and Ben comes in first, that's different than if Ben comes, well, so let's say Ben comes in first, then Chip, then Yoon. That's different than if Chip comes in first, then Yoon, then Ben. So the order is important. The order matters. So now the formula for that, and I never used this formula, but I wanted to show it to you because you're in honors, is the number of permutations of R objects taken from a group of N distinct objects is denoted by little n, capital P, little r, and that is n factorial divided by, and now you'll see where this ties into the warm-up, n minus r factorial. Again, I don't memorize that formula. I don't use that formula. You'll notice that as I do these notes, but I wanted to at least give it to you. Okay, so now let's go on to the examples. Okay, so now here, example 1. So some questions you want to ask yourself. It says you have 10 different colors. How many ways can you arrange 6 of the colors? So first thing you want to ask yourself is, does the order matter? And so what I mean by that is we have 10 different colors. So if I'm arranging those colors, so, let's say 3 of my colors are red, blue, orange. If I arrange those red, blue, orange versus arrange those blue, orange, red, that's different. So I need to count all those different arrangements. Therefore, what I'm going to do is just, 10 different colors. So to arrange those, don't I do 10, I want 6 different colors, so don't I do 10 times 9 times 7 times 6 times 5. 1, 2, 3, 4, 5 times 4, right? That would be arranging 10 different colors. Or and again, I don't use this option, but I wanted to show it to you. You could do 10, that's equivalent to 10 factorial divided by 10 minus 6 factorial, which is 10 factorial over 4 factorial, which is equivalent to what we did up here. Okay. Okay, so let's look at example 2, the letters in Tory. So actually what I'd like you all to do is go ahead and with your teams, try and figure out how we could, I'm giving you all the different possibilities of how to arrange the letters. I want to see if you all can figure it out numerically. So go ahead and do that and then come back to the recording. Okay. I hope you did what you were supposed to do and worked with your team. So the first one here, these are all different letters, and so therefore we can tell the difference between all of them. So this is what we've been working with. This is nothing new, so 4 times 3 times 2 times 1, and that would give you the 24, okay? So the key here is, the key here is that we have different arrangements. So, each time, so order does matter here, and we don't have any repetition, okay? I'm having a hard time. Now I see how you have a hard time with your styluses. Okay, and then down here, this next one with Adam, now we have something different because you'll notice that now the problem is we have different arrangements, but not within the identicals. In other words, Adam is the same as Adam because we have those two A's and we can't tell the difference between them. So we don't have any repetition here. So what we're going to do is we still have the 4 times 3 times 2 times 1 because we have the four letters to arrange. Now what we have to take into account is the fact that 2 of the letters are exactly the same. So what I'm going to do is divide out how many ways can I arrange those 2 A's. 2 times 1. So the reason we're dividing is the order of the A's doesn't matter. So that's why I'm dividing. Okay? So this is definitely challenging to see. All right, let's go to the next page. Okay, so now we have to add another twist. Now we have these 5 letters. So what we would normally do is, we can arrange those 5 times 4 times 3 times 2 times 1 ways. The problem is we have the L's are repeated and the A's are repeated. So what we have to do is we have to divide by, because I tell you there are 10 possibilities. Here's how you would do it numerically. We have to divide by how many ways can I arrange the L's? Well, there are 2 of them, so I can arrange them in 2 times 1 ways, times how many ways can I arrange the A's? There are 3 of them, so 3 times 2 times 1. And so what that's going to equal is our 10. So this here is the order. We have to divide out the fact that the order of the 2 L's doesn't matter. Okay? And here, these 3 times 2 times 1, the order of the 3 A's doesn't matter. So we're dividing out, we have to divide out the order, we have to divide by the number of ways the identical objects can be arranged, is what we're essentially doing. We have to say, well, we can't count these extra ways. I didn't write out all 120 ways that we could arrange those letters, but ultimately there are only 10 different arrangements. Okay? So let's go ahead and write down permutations with repetition, by the definition would be, or what that means is, we need, and I'm not gonna, you know me, I don't ask for definitions, but, you need to divide by the number of ways identical objects can be arranged. And by the way, I'm also going to post on Haiku my key if you have trouble following me here, which is much neater. All right. Okay, so I'd like you to try example 3 on your own, please, and then go ahead and start the recording once you've tried them. Okay, so I'm looking at Mississippi and realizing there are 11 letters, so I'm going to write that as 11 factorial, 11 times 10 times 9 times 8 times 7 times 6, blah, 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 divided by, okay, I have the S's are repeating, and there are 4 S's, and then, so I got to take those away, right? And then I also have the 4 I's, so I have to divide by 4 factorial, and then the 2 factorial. Here's the thing. If you can see I'm more concerned with the setup rather than the answer. If you are going to put this in your calculator, make sure the denominator is in parentheses. Otherwise, you're going to get the wrong answer. And so now for onomatopoeia, there are actually 12 letters. And then the repeats, I have 4 O's and I have 2 A's. Again, if you're going to use your calculator, and you are allowed to use your calculator, by the way, you would do 4 factorial times, divided by parentheses, 4 factorial times 2 factorial. Please make sure you show all your work, because that's what I'm looking for is the setup. So, looking here, oh, yeah, just a second. Okay, I had to get it so I could see, you could see that this whole next problem. So, find the number of roots. This is a pretty cool application, you might say, of the, what we're talking about here, the permutations. So, possible number of roots. So, obviously, if we're trying to get from X to Y, and we're only traveling south and east, well, the way I choose to go is going to matter. So I need to make sure I consider all the ways, but I have some repeats. So what I like to do is think of this as I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 south, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12 east. So 9 south, 12 east. Well, we could think of that as a letter, as a word, with 9 S's and 12 E's. That means we have a total of 21 letters, all right? So we have 21 possibilities, but 9 of them are repeated S's and 12 of them are repeated E's. So this turns out, and again, if you put it in your calculator, oh, this is the answer to this one. Sorry. You're going to end up with 293,930 ways that you can go from X to Y, but only going south and east. So now what I'm going to do is from X to Y, but I have to go via Q. Well, to go X to Q, I have 8 east and 7 south. Whoops, sorry. So that's 15 total, divided by 8 factorial, 7 factorial. If you were to multiply that all out, you'd get 6,435. And then to go from Q to Y, you'd have 4 east and 2 south. So now that's a total of 6 factorial divided by 4 factorial, 2 factorial. If you multiply that on your calculator, you get 15. You add those together. Oh, just kidding. You multiply those because we're going from X to Y and, so from X to Y and, which means, so we multiply Y to Q. So when we multiply those, we get 96,525. And this will be examples you'll see on your homework and possibly on quizzes. So the idea is you figure out how many total, I like to think of it as letters. So, I'm going south and east, or I'm going, whatever the problem tells you, and then divide out the repetition. So hopefully we're doing all right. Okay, so I'd like you to go ahead and try this next problem on your own, and then come back and check your answers, all right? So I'll go ahead and walk through it here. So we have 3 candidates for the positions. And order, it says, how many different ways can the statesman fill the 2 positions? Well, if Abigail is the editor and Boris is the co-editor, that's different than if Boris is the editor and Abigail's the co-editor. Therefore, I need to count all those ways. So, whoops, sorry. So, that being said, therefore, there are a total of 3 individuals, and there are 2 positions, so I like to have my 2 spots. We have 3 possibilities for the first spot, 2 for the second spot. Now here, how many different ways can the positions be filled with Boris as the editor? Well, so here's my editor, the first one, here's my co-editor, the second one. So therefore, I only have 1 position, or excuse me, 1 possibility for the editor, times, that means I have 2 people left for the co-editor. So that'd be, here is 6, here's a total of 2. How many different ways can the positions be filled if Chris and Boris are both chosen for the position? Well, now, both chosen for a position. That means it doesn't tell us which is which, so therefore we have 2 possibilities for the editor, we have 1 possibility for the co-editor. Again, there are 2 total possibilities. How many different ways can Abby be the editor and Chris the co-editor? Well, there's 1 possibility for the editor, and 1 possibility for the co-editor. So there's a total of 1 way, right? Find the probability of Chris being chosen as the editor. Well, that's the number of ways, success, divided by the total number of ways. So the number of ways Chris can be editor, we found that would be just like Boris being editor. So that's 1 editor, and there are 2 other people to be co-editor. Out of how many total possibilities do we have? Well, that would be our part A, so 3 times 2. Therefore, we have 1 out of 3. Or you could also have thought of that as, well, he's 1 person out of a total of 3 people. The sample space, just so that you have an idea what I mean by sample space. So sample space would be A, B, A, C, so Abby and Boris, B, A, B, C, C, A, and C, B. Now, what we're going to have is we're going to have a change in this next slide. So now you'll notice we have Catherine is added for the position because they want a columnist. So here's what a tree diagram is. So we have Abby, Boris, Chris, and Catherine. So let's say Abby's the editor. Well, that means I have 3 possibilities for co-editor. I have Boris, I have Chris, I have Catherine. And then from there, I have 2 possibilities for columnist. This would be your, this would be your tree diagram. So I'm not going to fill out the whole tree. You can look on my key and see what I did, but it is important that you know how to create a tree diagram. And then what happens is you can total up how many total you have by adding up all the bottoms. So they're a total of 24.